In the previous part of Milturn webinar, we talk about new operations and CAM-part settings, CAM-part definition with target and stock. Today we will talk about options in Machine ID, how to define and how to use them in machine control operation. So we have options for general options for machine, and all you can know that can exist on the controllers, like machine stop, optional stop, machine power, lights, door, coolants, everything it can be set up here. I will define for this machine machine stop on and optional stop. Let's say transfer mode, yes, I need to define because we have two tables and one coolant, let's say bed rising, the shower. Now for the upper turret I will define only rotation and axis synchronization, spindle orientation also. It can be value of. Why I define the rotation? Because I want the possibility to rotate the tool clockwise or counterclockwise and to stop the tool. Axis synchronization, I want to synchronize the axis for upper turret with axis on lower turret. The option is used generally in balance rough operation type simultaneous. So you send only one program for a channel with upper turret, and for the lower turret you only synchronize the axis, and the lower turret will copy the movements of upper turret. Now this is defined, and for lower turret I will define also rotation and axis synchronization. For tables, what I want to define is also rotation and spindle synchronization. I want the possibility to command the main spindle to spin the chuck, for example, 500 RPM, and with this command we'll operate the back spindle automatically. Spindle axis, spindle synchronization on off. Milling mode also. Milling mode is the function that change the status from turning to milling mode. That means the fourth axis is joined. Also for main spindle, milling mode on off. So when I define those options here in Machine ID, now I can use them and control them and operate them in machine control operation. Save and exit. Let's go to this part and delete all the operations. I have a backup. Okay. No. Open. I will open the backup. Let's see what's happened. Yep. Okay. The part was saved. New machine control. As I define in machine ID options for machine, I can operate them when I drag this item named machine here. I define that I can operate the machine stop. I have it here. Also the optional stop, and bed rising, on off. I can operate and shut it down. Transfer mode, the machine entering transfer mode. For example, in Integrex, in Mazak Integrex machine, we have some M code 548, I think, if I'm not wrong. And those options are for the machine. Now, in the same I can define for upper turret device. I define the rotation, so I can operate the spindle, rotate the tool from a clockwise with 3000 RPM. I can use spindle orientation, orient the tool in spindle on 45 degrees, and we'll get the correct command in G-code. The same is for all other options. This is the method how to use it. Now I want to define with you a transfer, an example of part transfer. Delete all. The machine that we talk about is the NTX. And what we need to do is to send the upper turret to a safe place, send the lower turret to a safe place, and prepare the back spindle with axis B3 on 0 degrees, open the chuck, clamping, go, catch the part, unclamp the main spindle, clamp the back spindle, unclamp the main spindle, and retract. Now, this transfer can be done in two modes, in milling mode or turning mode. That's mean with the tables, with the chuck joined with the fourth axis, or in a turning mode when I can transfer the part with the spindle is rotating. We will do the both now. Upper turret. Let's send the upper turret to a safe place. If I have some operations before and I need to shut down the rotation, I will shut down the rotation, and spin off, and movement. I prefer to work with machine coordinate system to send it to known limits. So X will go into 0 position with rapid, and Y also to 0, Z also, and B 0 position. Lower turret, also if I have a rotation, if an operation before and the tool is spinning, we will shut it down. Movement for X, retract an X to the home with rapid, and also for Z. But let's look in the machine simulation. Where is the best place to send the lower turret? I send the lower turret to 0. I'm going to make the retract. But for Z, Z2, here is the 0 point. I want to send this lower turret here in the left side, to the left limit of Z-axis. So here the value is minus 329, for example. Now let's see, what is the best place for upper turret? For upper turret, yes, it's X maximum retraction, and Z with B1 on 0 degrees. I can go with Z also 329. Upper turret movement, and also Y-axis. If I want to be more careful, you see the 0 position is here in the middle. Here is going to plus 105. I want to send him to minus 105. And minus. Save. Now I send the turrets to safe position. Now I need to prepare my tables. Main spindle. If I have a rotation before, shut it down, spin off, and we will define first a milling transfer with 4 axes joined. Milling mode on. Back spindle also milling mode on. And I make sure that B3 axis is on 0. Here I will already open the chuck on back spindle, clamp open. Also for main spindle, there are machines that when you send a command join the C-axis, you're entering in the milling mode. Also the C-axis is moving to 0 position. But if not, you can send it to 0. Back spindle also movement, C-axis to 0. Main spindle and back spindle are ready. Upper turret and lower turret, the lower turret are in the safe position. Chuck is open. I can start the movement. to the workpiece. Movement. And with Z3 I will select this option. With the mouse wheel you can move the back spindle. Now the steps are 1 millimeter. If you use control, the steps going to 100. And if we use control and shift combination, the steps is 0.1 millimeter. In this way you can be very precise to bring the back spindle into the right place, correct place. This is the value which I can divide this movement in the two parts. For example, let's add one. I will add new movement for rapid. To -400 and to this position with 200 millimeters per minute. Now in this position I need to close the chuck. Back spindle, clamp, close. And main spindle chuck, open. Back spindle. Now I will use part move, not movement, because movement is moving only my device. I will use part move because now device with part will be moved in simulation. It can be also the first movement with feed. Let's say get last location. I was here. I don't need it. This movement go to 400 with feed and go to 0 position with rapid. Let's see what we have until now in machine simulation. We'll hide the stock. Upper turret is going to safe position, retract. Now the lower turret and back spindle is going with rapid to clearance. -400 millimeters we define the first movement, and with feed to catch part position. Now the chuck will be closed for back spindle and open for main spindle. Those are our commands and code send it to machine. For now we don't see it in machine simulation. and the next movement should be go to minus 400 with feed and go to 0 position. So the transfer is done. This can be saved after you define a process like this. You can save it as a template. This is a milling transfer. And every time you want to use it, add the operation from template, milling transfer, OK. Just select the coordinate system and the submachine. You have the operation, the entire operation. Now, what more can we do to make it more automatic? Now, all movements that we define, for example, retraction of upper turret to a safe position, we can define them as parametric. So, for example, the X position will be 0 for me all the time. I don't want to make it parametric. Y also, this position is stable for me, and I want to make this Z position parametric in order to change it very easily, easy and fast. So this position, I want to make it parametric. Right click on that, add parameter. Let's say upper turret Z save point. For lower turret, the same movement Z. I want to define this point parametric. Lower turret Z save point. What else? I want to the position of chucks for a fixture. Maybe I want to transfer the part when the main spindle is on 0 degrees, the axis is on 0 degrees, but I want to catch it when the back spindle is on 30 degrees or any other angle, as maybe I have something on the part that it's not allowed to me to catch it in 0 degrees. So also this movement of CI can make it a parametric. Any of them, any value here, you can make it parametric. I will make just what I think I need to change. Okay, I will leave the names as they are, only for the example. And for back spindle movement, C-axis also add parameter 1. Back spindle movement here also 2 points that I want that will be changed from part to part. You have different parts, you will have different points where the back spindle will come and catch the part. Add parameter. And also add parameter, make it free. let's say that that's all for now, just for this example. Save, and I will save it again. Overwrite the old milling transfer. Yes, replace it. Now let's exit, save and exit, delete. Next time I want to use this template, add operation from template, milling transfer. I only go here to define parameters and change them. Upper Z save point, I want to change it, okay or not. For lower turret, C-axis for main spindle, C-axis for back spindle, and the catch position where the back spindle is coming to catch the part. Those 2 points. The same, I can define the feed, I can define everything. Any other value can be defined parametric. And you don't need to go and search where this device is doing this movement, or you have the parameters here, change them very quickly and easy. And you have another transfer process. Now, the second option to save this is as a cycle. Let's save it as a cycle. I'm also changing the name, milling transfer. Yes. Delete. Now, if I want to use the cycle, add a machine control, and the defined cycle that we already saved, you will get it here in this menu. I already have defined it before, a retract for upper turret, a retract for lower, and now we define together a cycle for milling transfer. It's very simple to use. All the commands are inside, save it, you see only the parameters. Change any parameter, you have the milling cycle process ready. You want to change something, go to General, you will get all devices with movements, with options here, and you can change it. But if you want to use only the cycle, ready cycle, and change the parameters, it's very easy to use for the user. Okay, so this is machine control usage. We can use this machine control. Without the machine control, we cannot have control on the complex mill turn machines today. Multiple turrets and multiple tables and a lot of options that we need to operate and to shut down and to control. This is the tool. Want to exit? Yes. Now, last time we talked a little about the synchronization. In a machine with upper and lower turret, with at least 2 turrets, yes, so we need to synchronize the operations. Turret synchronization. SolidCAM has an option in SolidCAM settings that we can synchronize automatic operations by country order. So as I defined operations, they are already synchronized in this turret synchronization interface automatically. If I don't want to be synchronized automatically, I can disable this option. Settings, turret synchronization, auto synchronization as in country order. So maybe the user wants to synchronize them. Let's delete the old synchronization, and the user wants to define his own synchronization. For this we have these buttons: synchronize selected operation start to start, start to end to end, and all operation as in a manager order. So let's take for example this operation number 11 from a upper turret channel to start together with a operation number 5 from lower turret channel. I will select start to start. They are synchronized. I can make them end to end. Delete all. So I will get synchronization points in G-code at the end of the operation. 11 on upper turret channel and after operation number 5 on lower turret. But you see here one thing, I can delete all the synchronization, but the balance graph remains synchronized. Balance graph cannot be deleted. The synchronization of balance graphing operation cannot be deleted. This operation is working together in any situation. It's not in our control here. It's automatic done, and we cannot change this synchronization. Let's synchronize them again by the country. This is about a turret synchronization. Now last time, okay, I remember. Another option, I want to close this machine simulation and open another machine. DMU 80 mill turn. This is a milling machine that can also turn up to 900 RPM on the table. And for this type of machines, that they are milling machine but with option to turning, table kinematic type, we can use when we have a turning operation on face, like this. I have a face operation and turning. Today I have the option to rotate this operation around the tool axis. You can see here another field, a new field, spindle orientation. That means the tool will be rotated around his own axis. I can make turning not only in ZX plane. I will rotate the ZX plane. It's an option on the machine. Have several reasons, not important. The important thing is that we need to support this option that exists in the machine in SolidCAM. So we did it. Now, the first operation is in 0 degrees. The second, I define it in 90 degrees spin orientation. Third and fourth operation in 180 degrees and 270 degrees. Let's see the simulation. It will be more clear for you. Now, toolpath also. We have a tool with insert only and STL holder also defined. This is the first operation on 0 degrees. It's turning on ZX plane. Now the second operation is rotated 90 degrees around the tool axis. You see also the tool is rotating with spindle orientation option. And the third on 180 degrees. I can do it every degree. I can do it from 0 to 360 degree in any angle that I need. The user, I heard about reasons that maybe you have the coolant tubes from this side, and the tool gets more coolant, a better cooling if you work on this side. Yes, there are maybe the chips is going to flying in this ways, better ways. Not to be deposited on the table or something. The reasons are many reasons and not important. Important for us as SolidCAM that we can support this function to turn around the tool axis when the table is on 0 degrees position, because if the table is going to be rotated, this function is automatically disabled. Here, you can see 1 degrees. When B angle is 1 degrees moved, also spindle orientation is disabled. Only when with table on 0 degrees, the spindle orientation is available. 1 degrees plus, 1 degrees minus, the spindle orientation is disabled. So this is the new functionality that we add for table mill-turn machines. It's also working on the Hermele MT, I think C42. We have a machine, and there are many others. Okuma MV500, I think they have the same table kinematics with turning possibility. Now, another function another thing that I want to show you is possibility. Okay, that working with B angle in a different angle than 0. This is the toolpath. So the simulation, machine simulation. The table is rotated because the vector of b-axis on 45 degrees, this B angle is calculated, is not what you see in operation. In operation is angle of tool around y-axis, virtual y-axis, but here in this kinematic we calculate the real B angle. I have also stock. And another option is using a removable device. So I build for this machine simulation 2 XMLs, one with a tailstock. We have a manual tailstock that we can mount on this machine. And I made an external program, batch file command. Tailstock is mounted. Simulate. Now you can see this tailstock can be mounted by the operator on the table, and this is also manually moved to the position. By the user, but I also can, let's see what I did here, tailstock movement, minus 190, save. I define an axis for this tailstock. And the first movement will be to support the part, and after it the operation will start. The tailstock can be used. So when you have the removable devices that the user can mount and unmount on the machine, we have this solution to make 2 XML files for machine simulation in the same folder, and with a batch file use XML with the tailstock and use the XML without the tailstock. Right click, external program, tailstock is unmounted. Now the next simulation will be without tailstock. We finish for today. We finished the VMID, turret synchronization using MCO and new table options on the Milturn. That's all. If you have questions, I am ready to answer. I also want to announce you that we start development for a Swiss type machine very soon, and let's see, maybe in 1 year we can have the first version supporting Swiss type machines, but we'll start the development very soon. Where can I see the questions? David, you are here. I don't have control on the questions, and if If you see the questions, can you read it for me? David? I think he's not on the computer. I will call him. כן, לא רואה בשנה שאפשר משהו, לעשות פה משהו סידי עשה, שאני יכול לראות. למה שלא? תשלח. Okay, see here a question. How do you know the back spindle should move to 419.8 to get the part? Why not 0.5 or... And let's go back to NC. Add machine control and select milling transfer. Make it general. We talk about back spindle movement here. I can go and make zoom. You see, we have the fixture that we define in setup. We have this drawing here. This is the fixture. Yes, this is our jaws for the back spindle. So using Control Shift, I can load down the steps. You see, this is a very accurate movement. So on point 8, I'm in the place that I want to be. Point 7, you already see that is not in the correct place. Point 9 is into the part. So how I know? In this way I know. I can make zoom and make it more accurately using 0.001. Yes. But generally the user is going to do the setup on the machine and measure the exact, take the exact position and come to SolidCAM and just input here the values. Yes, this is the way that the user works. But we also can, if yes, if you define the correct setup, yes, with the part is placed correct, depend on submachines with those values are correct. Yes, you can have very accurate values in transfer. If we don't have any other question, and I don't see any other questions, so we finished today. I thank you very much for your participations. David, we can finish, we can close the webinar.
Thank you, Florin, very much for a great webinar. Thank you, everyone, for attending, and see you in the next webinar. Have a nice day. Bye.
Bye all.